Okay, the last one we're going to do is a pH calculation. Okay, now this is from question 30, part 6 in the chapter review. And it asks for, well, first of all, it gives you 0.0016 mole of potassium hydroxide, and it wants to know the H3O plus concentration, it wants the OH minus concentration, and it wants the pH. Okay, first of all, the first thing you need to recognise is that potassium hydroxide is a base. Okay, basically anything that has a hydroxide ion in it is a base. Okay, if it has an H in it by itself, it's an acid. Now, potassium hydroxide is a base. It's a strong base, and we can assume that because it is a strong base, it is going to completely ionize. So, for every potassium hydroxide molecule, it is going to create a hydroxide ion. Okay? So when this thing dissociates into water, every single one of them is going to separate out like this. So therefore, we can say that whatever the concentration of the potassium hydroxide is, it'll be the same with the hydroxide ion. Okay? So our hydroxide ion over here, the concentration is going to be, so the concentration of OH negative, 0.0016 moles per litre. Okay? Because it's a strong base, the concentration of the hydroxide is exactly the same as the concentration of the base. All right? So, we actually did part B before part A here, because part A actually involves a little bit of working out. Now, it wants the hydronium concentration for part A. Now, the only way to calculate hydronium is from this equation, and it's hopefully one you guys will remember. H3O plus concentration is equal to 10 to the power of negative 14 divided by the OH concentration. Okay, now you might have seen that in a different format. When you have the concentration of H3O plus multiplied by the concentration of hydroxide, that always equals 10 to the negative 14. I've rearranged that equation to get this one. So the concentration we're looking for is equal to 10 to the power of negative 14 divided by the hydroxide. Okay, that's just something you should remember. So, put in our values, 10 to the negative 14 divided by 0.0016. And if you work that out, that will give us a concentration of 6.25 times 10 to the power of negative 12. So that's our concentration of hydronium. Now, the last thing we need to do, this will be short and sweet, is we want to work out our pH. And the pH, again, this is something you should remember. The pH is equal to the negative log 10 of the hydronium concentration. So you cannot work out pH until you've worked out the hydronium concentration. So our hydronium concentration is the one we worked out earlier, over here. So we put this into a calculator. Negative log 10 of 6.25 times 10 to the negative 12. And if you put that into your calculator, you should get 11.2. Okay, the pH of this potassium hydroxide is 11.2. Now, one thing I like to do, and I've mentioned this to a few of you, is put this to the logic test. Okay, is the solution you get here, is the answer logical? Now, the way to tell, potassium hydroxide is a base. Okay, we know, we worked it out, we based it on that assumption. Potassium hydroxide is a base. So therefore, it should have a pH of above 7. And it should be well above 7 if it's a strong base, and that's what we've got. A pH well above 7, that looks about right, we can be confident in our answer.